집에 가는 길 헤어지긴 이르지 너무 빠른 걸음이 이렇다 또 저렇다 나 집에 간다 내일 보자 너를 참 좋아한단 말야 다들 하면 거짓말처럼 사라질 것 같은 내일의 너 못 볼 것만 같아 미워 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 난 몰라 오늘도 널 기다려
It's always the wrong one, I think. Yes. Good evening and welcome to my continuing confusion over... Hang on, what? I pressed the wrong button. Okay. Over the sound output from... sound output capture in OBS, and also to Shenzhen I, where I think I'm getting close to the end of the second half of the plot, though I still haven't managed to sort out my daisy wheel printer. So we have this task today of a device to produce printable lattices for neural processing units that weave a growth medium around a nanoscale trellis-like structure. And there is actually the first page of a paper in the manual which discusses this. So I'm not sure actually it's going to be necessary for me to read that. Well, let's see. So yes, this one turns out to be very like my printer. So data is an X bus input connected to a computer. We have motor X and motor Y, which are simple outputs connected to precision motors, and which, very much like my daisy wheel printer, go for 100 to be move in one direction and 0 to mean move in the other direction. Valve alpha, beta and phi are simple outputs connected to a fluid print head. Oh, you sure? That looks like that's upsilon. Okay, maybe it's not. Maybe it's actually alpha, beta.
I think that's the thing that
Upsilon, yes.
later could describe as var-phi.
No, because it doesn't join up on the right.
Ooh.
Yes, that was what I read it as, but in particular, if you look at that.
Oh, that's right. Yes, that's psi.
Oh, psi. Sorry, I don't know my Greek alphabet. Yes, you're right, because upsilon is Y-shaped. So yes, valve alpha, beta, and psi are simple outputs connected to a fluid print head. There are two types of data packets that may be received: a 6-value packet that describes a 6x6 structure to print, or a 1-value packet containing over it only a -1 that instructs the printer to reset the print head position. A reset packet will never arrive while a print head is processed. Control motor X to move the print head right and left. Control motor Y to move the print head up and down. Control alpha, beta and psi to extrude different scaffold materials. Look in the supplemental data to find a document from Lisa explaining cellular scaffold patterns. But
Oh my god.
but I'm not sure. Oh right, so each of those numbers represents one of the patterns we might have to print. So there are 8 different numbers that can come in, each of which represents a sequence of alpha, beta and psi blobs. So I'm definitely going to need a quick note of these. And no, I'm not going to... Well, I mean, I could attempt. It appears that it pastes as A. How curious. Maybe it is an A, actually. No, I'm not going to attempt to switch to a Greek keyboard layout just in order to do this properly. 6 is psi blank blank psi blank psi. Uh, 7 is blank alpha blank 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 blank. And 8 is blank 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 beta blank. Right. 9 different things that I might have to print, each one of which has...
I just wrote an enthusiastic arrow pointing thing. Use this!
6 2-bit numbers, since we can have alpha, beta, psi or blank. And that's an annoyingly large amount of information. I mean, so we do them in sequence, as in each layer is... Oh god, and the layers are printed in alternate... This is hairier than my daisy wheel printer. So each layers are printing in alternating directions, which was something I considered adding to the spec for the daisy wheel printer, but decided that while that was authentic for printers with movable carriages, it was nonetheless going to be... Yes. Sadly, it turns out that that's what's required here. I mean, I suppose one thing that this has over the daisy wheel is that the daisy wheel can print 1,999 different numbers, and this can only print 9. But these ones are nowhere near as structured as the daisy wheels ones. I mean, because like the obvious thing is you stick the data you need in a ROM somewhere. Stick all of this lot in a ROM somewhere and then read them out in order to print things. But there are far too many of them, and each one is 12 bits, so that's too much to embed in a single number, even if you could do a sensible binary encoding, which would be a bloody nightmare with these chips anyway.
And you can't put the symbols consecutively in ROM and rely on the auto advance,
because half the time you're going backwards. Yes, so even if and that would require that would require 5 ROMs, which like
and then you have to add the code that it takes to decide which ROM to refer to.
noting that will mean they're connected to different outputs, which means that there'll probably be different code for setting each one up.
Yes.
So this feels like it must surely be necessary to take advantage of patterns, maybe, like, do we run length encode things? Because like we have got 4 and 5, 4, 5 and 6 are the same pattern, are the same patterns with different letters in.
So 1 and 7, so 2 don't.
Hang on. On one, I think 1 and 2 are all just all A's and all B's.
Yes, but I mean, if 4, 5 and 6 are the same symbols in every location, but different that's different one of them turned off, then 1 and 7 have the same function.
I suppose so.
I don't know, in a trivial sense, but
Yes.
never neglect the trivial case.
Yes, and I suppose, yes, you could do that as some kind of gating of individual outputs. So yes, you could take. I mean, no, I think that those aren't useful, but in particular, 5 and 6 can each be generated from 4 by simply disabling one output for the entire period, and that's.
Yes, that's true.
And that's the kind of thing that's probably not terribly difficult to do. This might actually be the first use of the mad programmable logic chip. Because, like, we might then actually be able to. It would be fairly easy to have an input to that turns on and off certain outputs, or something like that, maybe. So, like, the motor control is fairly simple. If are they always 6 layers? Yes. So it does have the advantage over the daisy wheel printer that the timing is fixed, and that was the thing that I have found most awkward. Is that the daisy wheel printer doesn't take a fixed amount of time to do anything. So that might make things more tolerable. In that once we've received a packet, we bet, for instance, the motor X and motor Y outputs are utterly fixed. And there's a slightly different one for if you're for when you get a -1. Yes, which is just you hold down. So those really don't need much cleverness. And once you've kicked them off, they can just trundle through things without having to have any synchronization with anything else. And like, I don't know if you could squeeze them into an MC4000. Let's code up something that can do the carriage movement, because that looks like it should be simple. Actually, we probably want something in between them, but still. So then if we receive an actual sequence of instructions, we go... Actually, we need a... So this is obviously going to end up too big if we attempt to actually do it as yes, I think we generate. I mean, I'm missing that slip one should actually. So that means six periods high, no periods low, and then no periods high, 6 periods low, which are that pulse and that pulse. But actually, that wants to then be a gen p 0 1 0 mov 50 p0. So, and then we need to do that lot 3 times, which obviously we can't fit into the amount of memory we've got available. So we could do an obvious loop. But that might require we end up with a lot of code if we actually write the loop out properly. Wondering if I actually stick the sequence for this in a ROM, cause that way we can just iterate through it and it'll tell us when to stop. So what would that look like? What if we did... I think I should just have this one, work out how to do the forward section first, and then we'll deal with reset later. If we had something like... Actually, no, we're going to want it connected to both ports anyway, aren't we? So then, if we did something like... Oh, but you're not allowed. There's a irritating restriction that you're not allowed to refer to. I can't write this, can I? It goes, cannot read pin twice. But what I was hoping for was to be able to have both the up and down operations be done with the same instruction. I mean, I can do it with MOVs and SLUPs, but that's... I mean, I suppose we could try it, couldn't we? Wrong way round. Rather annoyingly, having a set of instructions that's 3 bytes long is not going to mean that we wrap around nicely at the end. So what would the instructions look like if we framed them like that? They would go I've got X and Y the wrong way around. I'll fix that in a bit. Right, so that only gets us that far through the sequence, and we've essentially run out of ROM. But we replay that 3 times. And then we've done, then we've handled printing an entire line, which is quite nice. Except that we haven't actually reset the ROM in between. Yes, so then we need... Hang on, no, that's not right. That's completely stupid, Ben. Because we actually have to... That set of instructions only gets us reading one thing. We have to go... Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Of course. So that's a loop that will now actually continuously, so we need a bit more code in here, output oh, do we not have a... No, of course, you don't mean BNE. What language are you in? Minus jump. Okay, that doesn't work. I mean, it'll obviously all be at the wrong times anyway. Oh, no, that Movo Nortex 3 should have been outside that loop. Right, so that's got something weirdly wrong with my printhead motion, in fact. Let's just stick a slip 1 at the beginning so it starts at the correct moment, though this is obviously not actually useful for real purposes. Oh, because of course we don't move 6 spaces, we only move 5 in total, because
Now
it's
I
6
know what
spaces
you're
wide.
thinking. I bet you filled in that quoting correctly. You followed it with, now what you're thinking, my key factor is the last of me. You've got to ask yourself, do I feel off?
Oh, and then we fall into that slip there. This is all getting very hacky because it doesn't work at all, but... Right, there we go. Sorry, Pink Beast. I should try to be better at mentioning when I actually start streaming something. I mean, there's a reason why I have a 3-minute lead-in. It's not just to torture people with Jerry K-pop. It's to allow some time for people to find the stream and check that it's working vaguely correctly. Right. So then we have to have something that does this loop 3 times, and obviously we can't unroll that. And then we need something that handles the reset, but that's really quite simple. So essentially, when we fall through to here, we want to do I'm clearly confused what's going on. Let's actually watch the numbers in the registers. I mean, for one thing, that obviously shouldn't have been 2. But then, oh, because there's probably always something waiting for us on X0 that we really should have read ages ago. Okay, yes. Fine, time only lasts until 80. That yes, and then well, it's often the faster than trying to analyse whether you've made an off by 1 error is vary the numbers by 1 and see what happens. Right, so while...
The lowering code.
Yes, indeed, because I haven't written that code yet. I'm slightly worried because there isn't very much time to write, very much space to write it in. I was just wondering if I could use the other port of the ROM as a random counter, but I think that takes about as much effort as using the accumulator as a counter, in that you have to have one instruction to advance the counter and one instruction to test it. And like, we have got an accumulator available, so we may as well use that. So I suppose an alternative since the timings are all fixed, can we do better by having one processor driving motor Y and one processor driving motor X? If we do that, can we do without ROM? That slip 1 obviously has to turn into to slightly more code. So that fed 3 things on X0 at the correct times would do the X output.
Those some ways sharp sound like more kind of general all over back forward, but still a kind of sharp sound.
So then we can go, this one would just be so that probably needs to be a bit cleverer because this one actually has 2 different things it can do. Okay, that's looking quite interesting then. So then we need one more processor whose job it is to control those two. So let's make this one just know the timing of the first test for now. We'll make it actually read things, get control from other things later. Well, have I got these two? I've got these two processors the wrong way around, haven't I? Better. You don't need that mod 50 either, because it'd be in that state anyway. I've got enough here that I could actually do that. So I'd need another 3 instructions. We could do that, which would reduce the amount of work upstream. So we clearly have a problem here. Okay, we have several problems here apparently. I don't know. That's kind of amusing. Oh, because there's an extra slip 1 at the top there, yes. So now I kind of wonder if we can chain these together in the reverse order so that we actually have the signal passed from one of these two onto the other, and this one has a couple of spare instructions it could be using to do that. In particular, it doesn't need any spare instructions to do that. Yes, let's do that. So we can just change that into X1, and now we pass the data on. Since this one doesn't actually care what the signal is, it just needs to know that it's happening. Yes, we can do something like that, and thus remove those lines. Oops. means that that can now complete all of that. And then in the current setup, we then have 2 units of pause at the end. This isn't quite going to work, I don't think. Now, what? How did that ever work? Those are all MOV 0x3, which should therefore... does it just turn out that actually I was watching the wrong... Oh, yes. Okay, that was indeed sending the wrong data. Excellent, good. Just confirming that. Let's make it move in the correct direction. And then our problem is that so we're going to have to, as a temporary measure at least, maybe this one will have to be a big processor, maybe it won't. Wow. Oh yes, this one does need to pay attention to the data that are passing through, because it needs to not move the print head over to the right when it's moving to the home position. So actually we can't just do MOV x 0 x1 there. Oh, what has this done usefully, if anything, other than change the name of your kingdom? Wonder what that means.
Realms that have been de jure partitioned have been split into 2 same tier titles that can still be reunited easily.
Ah, right. So
they can't now. England and Danemark can't now trivially be reunited.
Right.
Probably.
Well, possibly the King of England might have wanted to. I don't know. Maybe you could have found this out and tried to unify them instead. But oh well.
It's true, but that probably still would have required taking over most of England, which was always going to be a bit.
Well, no, maybe the point is yes. I suppose it might not have been able to be done by agreement between you. Sorry, we're now getting distracted by Crusader Kings 3 over here. Which is a lot simpler. So we really need this to
This Friday, maybe not so easy depending on Thursday, but oh yes.
right. So that's the print head movement doing the right thing. It is admittedly hard-coded to the precise set of movements we need in this first test. So the chances are that we need to have something that actually pays attention to the input signals rather than just doing the movements. But on the other hand, who knows what shape all the other tests are. Maybe they're not actually that difficult.
Has that ever been a good assumption before?
I've got away with it occasionally. So essentially, that slip 1 needs to be cleverer, and that slip 14 might need to be cleverer. and possibly we actually have a processor upstream of this that can do clever things instead. Or that does some of the clever things. But I'm kind of here avoiding the difficult question, which is how on earth we sort out the actual printing. Like, and 9 different settings. 9. Like 8 would be, well, we've got 3 bits of input here. Maybe we can do something with them. But 9? So... like, there is clearly some pattern here. And these are perfectly normal simple outputs, which has the interesting consequence that they are wired OR. So we could perfectly well have different things generating the signals for different types of row. And then whichever thing is generating the output for this type of row could, like, do the right thing. So, for instance, psi only ever fires in those 3 columns. The other columns can never be psi. So, but there is a going backwards issue. There is some secret CK3 going on in Shenzhen, yes, in that, well, in Avalon City, in that Verity just over there is playing CK3. But not streaming it. I mean, maybe we could, but...
Also, I'm probably about to stop and go to bed, but I've just taken Lancaster back.
Oh, excellent. Well, that's what they get for leaving the Byzantine Empire, really. Yes, it was. In this world.
It was a bit exciting.
Which meant that Verity always had in her list of people you can go to war with the Byzantine Empire. Yes.
Yes.
Very rarely a good idea to go to war with the Byzantine Empire. So... I suppose those are quite... like, if you were to program that... the psi things, it would be... something like that. Like that's one row of psi output, and then if you insist on having the backwards one available as well, Good night, Eek. And a backwards psi row looks like that. So, like one can imagine, if one even need imagine, a processor that was like some condition which I haven't quite worked out yet to decide which direction we're going in.
There's a mustard cascade problem.
Then emit a forward psi row or emit a backwards psi row. So if you imagine something like that with P1 wired up to psi, let's shift that gate array out of the way. Then that can successfully print psi rows, albeit that it prints them in at the wrong places. What exactly did it do there? It appears to be doing the correct thing, even though I wasn't expecting it to do that. Excellent. Good, we like that. So that's a fairly simple generator. So what other generators do we need? So, I mean, those ones are really trivial, 1 and 2. And 0 is obviously utterly trivial, but we don't need anything to do anything for that. So now we could have a processor that has one pin wired to alpha and one, or a collection of processors, each of which has one pin wired to alpha and one pin wired to beta, and that knows how to emit one pattern, possibly in both directions. No, we probably can't, it has to be quite big if it's going to emit them in both directions, doesn't it? Um, so I'm thinking, oh no, but really we want, I don't think that's actually what we want to do. I think we want to try to do smaller fragments. So for instance, how about the alpha in 4 and 5? That's essentially the same process as psi, just with different numbers. So it's 0, 2. Sorry, I mean 0, 1, 2, 1, 1, 1, or in reverse 0, 1, 1, 1, 2, 1. Appear to be backwards. Oh, possibly because they're both backwards, yes. Let's just put that one back in and check that that also goes backwards. Yes, that is also backwards, Stodes, right. Because I've got my pluses and my minuses the wrong way around. Right, so now that should do the layout that's actually in the diagram, yes. And so will that, and were we to run 2 copies of that program, then we get something that looks like that, which is what we wanted. Right. So maybe we'll get away with this. I mean, the tricky bit is going to be whether we can get all of the wires in place, really. Right, conveniently, this is the only way you can ever generate psi. It may not be too bad, actually, because we can wiggle the tracks through other processors as necessary. So then the question is, what do we do with modes 1, 2 and 3? Because we've now got things that will generate the various components of 4, 5 and 6. 0 is obviously trivial if we're doing things by just oring together the various ways we can output stuff. 1 and 2 can probably be done in a single processor. I mean, obviously we need a sensible way to signal to it, but and then we have 3, 7 and 8. Because 1 and 2 are direction invariant, which helps. If I do anything like this, I'm simply not going to be able to connect beta to anything, am I? This is a bit of a nuisance. So if we do this, and temporarily disable these two. And that should give us alpha and beta emissions. Right. There, that even gets the first two rows correct. So we have ways of emitting 0, 1, 2, 4, 5, 6. And these three processors are just test rig, so we could probably dispose of them. How much we can shift others out of the way, I'm not sure. So those three handle carriage movement. And those need two tracks running into motor X and motor Y. So that processor in particular could easily, if necessary, be moved left to give us give us a bit of extra space. So, I'd quite like to stop before midnight, but let's see what else we can achieve. So, in particular, that one still has a load of extra code space available. Kind of wondering if we could fit 7 and 8 into it. Problem is, if we're going to work on the approach that, let's allow for, there will have to be something upstream of this lot which is quite complicated, and then see how complicated it ends up. So this one can now, by being given various inputs, produce rows 1, 2 and 7. And it produces everything that's necessary for 1, 2 or 7. That one produces the P necessary for 4 and 6. This one produces the Psi. This one produces the alpha necessary for 4 and 5. In every case, if you send 0 to something, it does nothing. This may turn out to be important. So, kind of, insofar as I have an idea, it's that something wires up to the X-bus inputs of all of these processors and sends them the right things once a line. And just has a big list of what it sends to each processor to generate each output. So the things we're still lacking, So we've got 1, 2, 4, 5, 6, 7. So we're now lacking the ability to print 3, which varies by direction, and 8. I observe that 8 is just 7 backwards and with A and B swapped. So, like, that would be one extra instruction here, but the only problem is that it's that then we also, that we need to be able to print both of them in both directions. So we essentially have 4 different ways that things can go, and we've only got 2 condition flags. Well, let's sort out 3. So 3 annoyingly needs both access to both alpha and beta. No, that's not good because that now can't be connected. Well, we're not going to be able to talk to the outside world for a little while anyway. So if we're in the forward direction, we generate alpha first. So it's now, that one's disabled, that one's disabled, that one's not actually wired up yet. Right, so that's correct. 2. I think it might be backwards actually. Forward direction, we generate alpha first. Alpha is red. Why are we emitting green first then? Is that because... Oh, because that's sending -1 first for reasons best known to itself. Right, yes. That's fine. Right, so that correctly generates 3 in both directions. That's a rather tight fit in that processor. I mean, obviously we might, well, if we wanted to make it into a loop, we'd need reset the accumulator, add 1 to the accumulator in each loop, conditional jump, compare conditional jump. Or you would have to add 4 instructions to implement a loop. And we would have to have 2 instructions in the loop. So it isn't, that loop is actually shorter unrolled. Right, so we still can't generate 8. Because I'm kind of wondering if I can come up with a way to cram it into this processor, but I don't think I can. Which is kind of annoying because it only needs half a processor. Plus there's like the slight shortage of space here. In fact, it needs about 1 more instruction than we have here, except that that would involve very careful timing by other bits of the system, which we don't want to have to do. So, well, maybe we sort out the control code and don't worry about the fact that we can't print an 8 yet. Because maybe I'll come up with a clever place to put that. So let's just dispose of all of the testing processes. And we should probably try to work out how to lay this out such that we can get an X bus input into each of these processors, and there's some access to the beta valve line, or maybe the alpha valve line if that's easier to achieve, because we can easily swap this one over to being able to do 1, 2 and 8 instead. For an extra processor to connect to it. So that track can't get out of that processor because it needs to be separately wired to P1 and P0. On the other hand, we could get beta out here because... Oh no, we're not allowed to do that. Okay, that's annoying. Oh, sorry, no, we don't want to get psi out there, we want to get beta out there. Which we could do like that. So those are the only 2 things that need to wire to alpha, aren't they? Oh no, sorry, 3 needs to wire to alpha as well, doesn't it? So we need to get alpha out. Which means that can't go quite that far in unless we start clearing out up here, but actually moving that processor sideways won't help. else. We need to move that further that way. For a reason I've now forgotten. Oops. So that then that beta wire, that alpha wire can escape because we still have a use for it. Because somehow we still need to get both alpha and beta wired up to this. Oops, yes, that's not what that's meant to be wired to. That's beta. It's a lot trickier. Actually, we can simplify this a bit. Because that processor doesn't use P0, so we can route through it. And it allows us to shuffle that in a bit. But we still have the fundamental problem of getting valve beta into the right place, and we only have the ability to bridge one track at a time. And that would do what I want, except now that means that X0 there is unconnected. Possible that going to bigger processors would allow me to get more functionality in one place. But that does end us up with a huge... Well, I suppose then we might be able to start daisy chaining them, but it takes a lot of effort to get to the simple output, simple I/O pins of big processors. They're kind of messy. They take up a lot of space. And like the one that I most think we could usefully add extra code to is this one, to get it to support 8 as well. So if we were going to go for a more regular layout, what could we do? I mean, we could actually stick this processor way out over here because it only needs to connect to Psi. And similarly, that one only connects to alpha, and so should really be right out of the way. Because we only need to get 2 tracks out of this area to reach those 2. And it's the ones that connect to both alpha and beta that we really want over here. So if we wanted to do that, let's scrap all of this because I kind of hope we can, with more logical layout, do better. So that would suggest that the one we want furthest over here is this one, on the grounds that it's tiddly, and needs to connect to both alpha and beta. Now that's, I was going to say that's obviously a terrible layout, but that gets us alpha and beta out there, and Psi can come out somewhere down here. Let's assume that that bottom row is dedicated to getting Psi to the Psi processor. So now we have alpha and beta. We do also have a slightly embarrassing X bus in the middle of them. So let's extract that. So then what we want is the other alpha beta processor, which is this one, which I'm going to expand. I may want to swap its outputs. So then the idea of that is it wires to alpha and beta just like the previous ones. Now, it's quite important. Oh, so I think this one therefore actually wants beta on P1. Because then beta doesn't have to go any further left than here. So then that naturally dumps that on P0, but if we route it that way, then the X bus from that processor can't escape. can it ever? Because like that's all very well, but we need to get that X bus over that simple I/O pin, and that needs us to have 3 units of vertical space, which we do not have. Like what I want is a horizontal bridge that I can stick in there to connect those two. No, that's obviously swapping those two around won't help. Feels like all of these jinks upwards want to be dealt with by straightening things somehow, but that would really involve routing psi somewhere else, or this being a smaller processor. So if it were to go back to being a small processor, we would need to be able to get beta out of the other side of it, which would essentially use the one extra row that we would otherwise have. Like, strictly, that accomplishes what I want to accomplish, but it takes up so much space that it's really not actually practical. Right, we can stick an MC4000 in there, for instance, to wire up to beta. But the problem is that, well, actually, if we have this, so that's currently 1278, how about if we instead have an MC4000 here that can only do 1, 2 and 7. So it would still only need to be wired to beta, but it would still be the only thing left needing to be wired to beta. It would, of course, also need to be wired up to alpha, which is kind of inconvenient. But, like, not impossible. Obviously, there are problems with the fact that it doesn't have an X-bus connection at the moment, but... So the idea is that it would be... One, 2, and 8. And then we'd need to drop in a separate 7 processor. It's not very helpful. I'm trying to get over this X-bus track. Yeah, that's nice. Where is it? I mean, it's not like this X-bus has anywhere to go yet. But... So that will do that, but we do have a bit of a not having any space problem. So yes, that we've got all of the processors that would generate the output, but we have no space to put the control system that would work out what to signal to what of them. But that's not so much because we don't have enough space for processors as because the board layout is becoming terrifying and I can't work out how to improve it. I'm kind of wondering if this means thinking about programmable logic next time. because maybe I can have the programmable logic here and have that implement a lot of the different things. Though I'm not sure, because we do have quite a tight space problem here. But like maybe it could drive alpha and beta somehow. Like there could be, I don't know, can we sensibly have that, have the programmable logic gate generates the square wave and the constant ones? I don't know, but I'm not going to try to sort that out now. We've got things that can output everything. I just don't seem to have the space to get anything else installed, and that will do for now, I think. So we will leave that there and hopefully come back to it in a week or so and see if we can sort it out better. So yes, I think that'll be all for today. Good night, and we will see you later.